Good morning, good afternoon, and good evening. Today, I'm so happy to welcome you at our webinar about compressed air, pneumatic systems, and Direktin technologies. My name is Elvira Rakova. As you probably already know me from LinkedIn, or I'm happy to welcome our customers, our clients, our friends, and also fans of our Coffee and Compressed Air show, as well as all people that are skeptical about our platform and about our tools. And why we decided to do this webinar today. And for those who couldn't join, of course, we will have recording. You can reach directly to me. You can reach directly to our team members. So I have an amazing team of 6 people, of our great engineers who've been developing the products and supporting our clients. And so why we decided to do this? The main question that we always was getting, what the Direktin is about, what do you have? And in the past half a year, we actually developed so many tools, and we were developing new, then we were changing them, then we'll develop another one, then they would just adjust. And now, finally, we are at the point where we would like to have, where we would like to show you portfolio. And it's actually nice because all different tools are for all different types of users. And I was actually talking to a colleague of mine, and I was asking, well, how would you position EasyCAS? Because he was working in the simulation and in the modeling tools. With what it is to compare, with what, how to sell it, also how to show it, how to bring the added value. And then he said, well, you're not competing against other simulation tools, you're actually competing with Excel. And this was an amazing point, because I mean, I'm losing in the competition against Excel, but it's not the competition against Excel, but it's competition against also opinions of engineers, of some other practices of engineers. And I mean, there are no other opinions about the physics, right? Physics everywhere the same. And this is why I would like to show you today what types of tools we have, from the simple calculation to the simulation. So we will keep today's webinar for 30 minutes, and then we will have few questions. So please don't hesitate to reach out also directly to me in DMs, because I noticed that from my previous conversations, usually the people like to reach out directly and rather not asking the questions in the comments. So it's all fine. There are no stupid questions at all. And we're developing, and we hope that we can actually bring value, and we want to become your own personal Excel that actually can free up a lot of your time and will not make mistakes, and that you don't have to think what calculations to put, because it's been everything already proven and tested. And well, let's start. I see some people in the comments greeting, and grab your cup of coffee, cup of tea, water, glass of wine if it's already evening for you, wherever you are. And we start with our platform. So I'm gonna just share my screen, and we'll continue our exciting webinar. So you should now see my screen, and perfect. So if you see it, let me know what you see, and if everything is fine. And here I would like to start with the simple tools and how to navigate our platform. And first of all, it's of course our quick savings tool. So if you need just a very simple calculations, and you don't want to log in and you don't want to register, we don't oblige you for this. So you have a lot of free resources that we've been collecting for the years of engineering and the research for the past 13 years, my personal experience, our engineering team, and who have another 15 years of experience programming and so on. So you have a series of tools here, and you even have some education tools. In case you are, these tools actually used for my lectures at the university. In case you want them in English, because it has some cost calculations, the pneumatic resistance calculations, generation and sizing. You can see here the explanation of the sonic conductance curves and valves and sizing of the components. I don't know why I decided to start with this tool, but I really love it because I used it a lot in my lectures. So the sizing of the generation, you can show your student also the cyclogram, for example, and let me know if you need for your educational and training stuff. We have these tools, and we also, of course, have them in different languages. This is the first one, educational tools for lectures, and I'm personally proud of myself because I use it with my students to get more experts in our field. Right? We need more experts in compressed air. So then we have other tools from the nozzle blow-off calculator, leak cost, pressure drops, compressor cost, cylinder dryers, filters, and compressor loss calculator. Please note that we actually add one tool every 2 weeks or every month. So every time you go there, you see a new update, a new tool coming there. If you see that something is missing in this tool, just let me know, and we will edit. So we are very, very quick in engineering. So how it works, very simple. Again, note that it's not a system level of view, it is a component level of view, meaning that you actually, in order to get the full system simulation, will use other tools. But here, I would like to show you how it works. Imagine that you walk in the facility and you have a drill pipe. Either you're auditor or energy manager or operator, and you want to convince your folks in the facility that it's actually not the best engineering practice because it doesn't make so much sense. From the performance point of view, or also cost performance of view, you can put, first of all, what you do, you put the information about the cost of compressed air because everything is based on the cost. You either can put it manually if the data is already available for you, or you can calculate the cost of compressed air, or maybe you have some audit data, for example, how much already the customer or how much you already pay for this. So after we put all this information here, we put also our operating condition. Also on the right corner, you also can change your system metric or imperial, as well as you also can put your currency. I mean, it will not recalculate the actual live currency, but you can use it for your own calculations and for the sake of the reports. So then we have information about the pipe length and pipe diameters, as well as number of holes. You can put also how many machines you have there, how many open pipes, open tubes you have per machine, and then already get your first calculations. And here what we see the flow, we have the power, we have the cost per tube, and as well as other parameters, the facility demand. And what is very important is the facility cost, meaning how much actually the open pipe cost to operate. And then we have recommendations of the efficient components that can be replaced here. And here, these recommendations based are only on physics. We have suppliers in our platform that are already integrated, and we use the data from their catalogs. So meaning that if you don't want to take the supplier, we don't oblige you, but what is important that you have the information about the facilities cost, you have information about the demand calculation, and basically all physical parameters that then you can use in order to find the better component based on your engineering experience. Or you can simply go here into the recommendations and analyze what is actually this is a component. You also have here a matching product for this, and again, Direktin what I think it's very important also here to say, we are a brand neutral platform, meaning that we recommend everything based only on physics, based only on the database that is available now. So we have, for example, the supplier for the air knives, and here you have the recommendations. So what you also can do, you actually can request the bill of material from the supplier and then compare with others, for example, that you use. Or if you're a supplier, you actually can also integrate your component here to help your customers to make the choice of the components easier. So once you can edit them in the bill of material, then you can send the request directly to the supplier, and I'll show you now. If you're not logged in, you cannot do this because then it will be hard to get the request. So you just simply go into the view of the component and you send the email yourself. But I mean, here is way easier and it's free free to use. So we have also here for the drying applications, you can see what is the single orifice also will do. And then we have some calculations such as liquid cost calculator. So again, the leak cost calculator is of course not a real leak cost that you have in the facility, in sense that it's not a leak detection device. It's rather to show how much the small leak will cost for you under this pressure level in this operation hours. This is more to sensitize customers, or sensitize also your management, or maybe also motivate yourself to get the leak detection test done in your facility, get the ultrasonic devices, and just go around and just do it. So I think this will be a really good thing. Pressure drop calculators using ISO 6358. You can check the existing piping, see what is the pressure drops there. It helps me, for example, to understand during the audit or during the analysis, I get what is the flow, what is the main header diameter, and if I know the flow also from the compressor, I simply can see if there is and the customer says, oh, I have a pressure drop here somewhere in my facility, I don't know where. First thing is just to check one header without doing some crazy simulations that probably you don't want. So, and then also size new. This is like the same thing, is that within a certain threshold of the pressure drop, you can actually check and size correctly the diameters. Compressor cost calculations, the same thing, based on the power and the load, based on the specific power. And compressor loss calculator, this is something very interesting. So here, for example, you also can see the impact of the temperatures of inlet, of outlet, the pressure set points. You can see the level of the clogging of the cooler. And again, so this is only the diagnostic, it is a calculator. It's not connected to the real measurement. So please pay attention. That is first estimate for your system, rather than the full final audit that you can base all your calculations on this. Filter and sizing calculator, the same thing. You can get different types of filters. You can calculate them. You can see what is their let me see the results. And here, for example, you have the minimum filters capacity, inlet pressures, the pressure drop. That is actually depends on the model. So here, for example, we also have recommendations from the suppliers that are presented in our platform for filter and dryer technology. We have great supplier KSI. Again, you're not obliged to buy their components. It's rather than the recommendation of the matching product here. If ever anyone wants to join our platform and it's going to be another competitor, you will see exactly the same same recommendations, but now from the from two companies. And then you can actually add it again to the bill of material and then request a quote for this. So sizing of the dryers and the cylinder calculator. For me, it's extremely important because I actually use cylinders like all the time. So I do the calculations of the cylinder all the time. And here you can calculate the conditions for the cylinder that already exist from the standard diameters. You also can calculate it with the operational conditions, or you can calculate required diameter. And then you can see which one it recommends you from the catalog. And then you basically have here information for the kinetic energies, retraction, and pull. I'm extremely proud of this calculator because it was first ever calculator actually done with my dad. So many years ago, because it's not so easy to find very good physics-based online calculator. From some suppliers you can find it, of course, but sometimes it's just recommendations of already existing cylinders. So we go on, and again, please track all the new calculators. And I ask you, if you don't find some calculator here on our platform, please let me know, and I'll be so happy to integrate more and more here. Of course, we cannot stop in the online calculators, otherwise we wouldn't be the platform for compressed air and pneumatic systems. And here we go to a dashboard. So dashboard, it is our platform that we're like extremely proud. So this is the portfolio. Basically, this is all the project on all the systems that you work on, because we don't have only the let's say we don't have only online quick savings tools, but here how the logic works, also the platform that you can do the full work and the full audit or analysis or simulation of your system. And here how it works. So we have a few tools. So here we have a systems. Here we have a bill of materials. So this is the tools that I just showed you, that you can just simply add your core components here. Here we have a quick savings tool, and this quick savings tool that you use, you can then save inside different systems. So systems is basically your project. You work on one compressed air system, and this is your project. And here we have following things. So we have compressor room tool, we have a business case builder, and this is analytical tools. That, let's say, analysis tools. So then we have a data analysis tools, and there we have a data collection already and the measurement upload, as well as the site audit. So measurement upload and site audit, it's beta tools. And if you work with a lot of data in the facility and you want to test it and gain like an early access to those tools and easier analyze the data from them, compressor measurements, for example, and then uploaded it already into the simulation of the EasyCAS, you are super welcome to join our beta testing group. Just directly send me a message and I'll include you there. It's extremely important for us to perfect it. And then we have engineering and the delivery. This is already cherry on the cake. This is our baby. This is our main tool. Simulation EasyCAS, I'll show you in a few, and I'm sure you saw a lot of videos also on internet, and Project Studio. So let's go. And we have, of course, our suppliers, our ecosystem, the catalogs, measurement tool. And let's go and see what we have here. Well, compressor room, extremely important tool for me, for a person that comes from the demand side. And actually, I used to simulate, and I still do the optimization of the demand side, the production lines of the machines. Without connecting it with the supply side, I must say it doesn't make so much sense. It can be also very frustrating when you don't know the cost of the compressed air, but you don't know behavior of the compressor room, when you actually cannot deliver for the client the full picture. This is extremely hard. So here you can have you simply start the new project in the compressor room. You have here the information such as operating point. You have the information about the network pressure, maybe some information about the demand, or okay, I'll mirror it here. And here you have your compressor lineup. So what we have here, of course, the compressors from QG data sheets. So here you can find, again, we're adding them every single day, more and more compressors. So here you can find some few of them. If you don't find them, you also can have a manual entry. So model names, rated pressures, capacities, control mode, and so on, as well as you also can actually import it from the CSV file, also the information about the compressor. So here you have the setup of your compressor room. You also can choose what is it base, it is backup, is it swing. And here, based on the load and unload and also all these parameters, you actually can see how the compressors behave. Here you put the demand side during the production hours of hours. You also put here electricity cost, grid emission, and based on the put here like this. So here it's also changing for each single compressor, also the part, and you can put also here, for example, 12, and here you see here it's changing the current room state. Now we have two compressors that are loaded and one compressor that is modulating. Again, pay attention. This is the calculation simulation. It is not connected to the real measurement data. So this is the condition of the compressor that we can size the compressor room. We can check also current status, meaning that we can get the data from the compressor, the how you call it, like the name of the compressor plate, put it here, and the data that are from KEG, from Compressor and Gas Institute, it's inside here. So we need to trust it. So it's not a measured data yet in this tool, right? But it can give you just the first ideas, and it can give you first information on how to use it further. For example, then for the simulation and modeling, and also for the next tool with measurement, because actually very soon you will be able to compare it once you put some measurement, and then you have this information. So here we have what we actually have here. So we see the demand, we know the hours, the average room kilowatt energy, the cost. This is very important. So this is then we use for the baseline, and as well as the CO2 emission. So the grid emission for CO2, as well as in the EasyCAS, usually we just use the coefficient that you can find online for each country or for each region for the country. Now the information here, you also can put here logger data, of course, and you can extract this logger data and use it for the simulation. So you use here CSV file, and we will have, I think monthly or maybe bi-weekly, we will have various sessions dedicated to each single tool, going step by step, because I just it's been already half an hour. But if you have some questions for each single tool, again, just let us know, and then we'll help you to set it up. Sometimes maybe it's not very self-explainable, some things, so we'll be happy to set it up for you and go ahead with this. So then what we have then, some calculations of the fully loaded cost. We have also the for cubic meters for CFM, and this is what we use this data then for EasyCAS and the simulation of EasyCAS, because there we need to know how much 1 cubic meter costs. As you remember, in quick saving tools, you actually just estimated it from one compressor, all right, from just one demand, one generation. In the compressor room, you already model it with the actual compressor layout. And in the measurements upload, you will be able to have an actual data once you have an actual calculations. I mean, I'm sure that the auditors that are watching us, you have your own Excel for this. Now we provide you, please use, let let this be your Excel. So, and this is basically, we have some baseline, we have information about the compressors, and I pressed the button, was too quickly, but you can replay it if you have the recording. Pressing by the integrating the compressor room, it shifts us into the business case builder. And business case builder is a very exciting tool, at least if you are not an engineer. You don't have to be afraid of the compressor systems because it doesn't require engineering, simulation engineering skills here. So you can work in business development, in the maintenance, in sales, for example, to show the customer, or to show also yourself, calculate yourself, what are the possibilities of savings in my facility. So again, this is a business case builder to start the conversation in general. So we don't just say, oh, usually here you might save 35%. It is not exactly very convincing thing. What is very convincing is that if you have 5 facilities you work with, you register those systems here, you create business case builder and compressor room, set up compressor room and business case builder, you share it with your client, because you actually can share it with your client. And then you already go and you start the measurement of this, and then you start an actual project. So what we have in business case builder, and we try to do it on purpose as Excel look as possible. Again, no sarcasm here. This is exactly, I think it's a very good idea to have it look like this. So we exported compressor fleet from our compressor room. So we have the installed power, we have the information about the cost, and so on, so on, so on. So I think I have here another compressor room, but anyway, and here you have a different scenarios that you actually can have. And scenarios will have some baselines, so it can be conservative, realistic, or aggressive scenario. And it already suggested you some numbers that, of course, depends on the customer, depends on what you see in your facilities. You already can adjust. So here we can, again, import the baseline. We can have some pressure scenario data, meaning, for example, that here I uploaded another compressor fleet because I wanted to swap one compressor with another one. But then I also can see another information. And I can add the different layers and levers for this. I can customize it. And say, okay, I see that I can reduce your demand side. I can reduce, I can optimize the network. Maybe I did another quick saving tools calculations, and so on and so on. So you can customize it. You can choose from here, based, of course, on your experience that you see. And here, what I put is the current leaks volume, how much I want to remove from this one, what is my capex for the leak detection, what is my leak repair capex, and then I calculate it. So then compressor room control upgrade. Again, this is everything based, why we call it business case builder, because we start the project. We see what the possibilities are in general, and basically if we can qualify this system for some improvement. Very good point also on compressor heat recovery. You also can switch it off, you can switch it on, and then see how it impacts the full ROI. And here, what we have, it is the cascade. So the electrical levels plus the heat recovery. So we have a baseline, the leak elimination, compressor control upgrade, heat recoveries, and this is basically your baseline on what is possible to do, what would be the magnitude of savings, and what would be the ROI on this. And then we have also additional things, and because we are demand side experts, experts, and we actually have the full tool for the demand analysis. This is the just add, okay, I actually see the opportunity for the 10% improvement of this system, and maybe I put some engineer nozzles there or something else. I'll calculate it and simulate it better once I have the more data information. But here I can just include it, and then I already have the full idea of my estimate for this system. So I also can put some cost there. I can put my analysis cost, the audits cost, the repairs cost, and here you can see all the sum up, as well as you can see the payback. That is huge because the system is small, and I put here, for example, the heat recovery that was costing a lot. So I removed it. Now I have like 2.5 years. That is also huge ROI. So meaning that maybe in this case, it will be not so interesting for customer to to work on this. And I need to find another levers. I check the demand side. I check also the additional opportunities for the pressure set points, other levers that I have. And maybe after the first leak detection audit, I see that I have way more leaks there. I can repair more leaks there. And my calculations here, for example, become a bit slightly different for the entire system. So this is why it's important to start with. And basically, once this is complete, we can then go into the data collection tool. The data collection tool been here for some time, and we got a very interesting feedbacks about this because we have a very simple summary there. Once the system is collected, it shows the data confidence. It shows what you can complete, what is missing there. It gives information on the demand side, measurements, and so on. It is literally a data collecting tool only. And we actually have, apparently the report from this tool was so good that some auditors use it as an audit report. And we had actually to put this line telling that it's not an audit or engineering report. This is only to collect the data. And it helps you then to summarize the information that you have here, all the measurement that you have. Take photos also from the facility, and asks you also correct questions for each single part, from the distribution system to the demand. And it actually makes you to try to add some information about the point of use photos, demand photos, and all other information that gives you then the data points. And it is a good tool to start getting more into the simulation and into the measurement. So we also have the measurement upload that is coming soon, as well as the site audit. The site audit, it is the tool that you can collect, it's uploading the photos, and it basically then reads all the information from all those photos. And after the information is read, it creates the CSV file. And after the CSV file is created, you have also some gaps in the nameplates, for example. So it's just a data photo analysis tool. So you can then send this to the compressor room, or you can just upload it. So you have a simply information. Okay, here I have two compressors, one dryer, field task controller, receiver, and there is like some 7 gaps from the photo. So it's mostly for the auditing purposes, and it is mostly for the collection of the data for the information. So, and once we collected the data, we analyzed our baseline, we know how much cost our compressed air system, we can go into our EasyCAS. And the question I see in LinkedIn, all these tools can be found at Direktin.com. All these tools can be found at Direktin.com. Exactly. So again, if there is something missing, let us know. and you can just simply use it. So then we go into the exciting tool, at least exciting for me. I know it's going to be a 10 minutes of more like nerd conversation. But so once again, we did the first small calculations. We did the assumptions. We checked information from our compressor room. We know the generation. We know important data such as pressures at the compressor room, compressed air cost per cubic meters or CFM, hours per day, days per. So here just I put just all hours per year, and so on and so on. Electricity cost, very important, normal temperature, ambient temperature, pressure also. I actually saw some tests that have been recently done that were not considering the ambient parameters. They should be considered everywhere in tests, in the simulation, in calculation. It's extremely important to work with the thermodynamics equations, to work with the compressible flows with the low pressure levels. So please don't forget. I mean, in the mountains, in the heat, you will have completely different, very different actually outcome rather than we have it now. So here, what we actually see, so we collected the data and we set up our generation part. So here it is a easier scenario, simplified scenario, meaning that I have just one compressor room here, one compressor representing the compressor room. So just to make it easier now, so don't go into the full model. We also have here the thing that calls a cyclogram, and we have a video of the last coffee in compressed air, pre-last coffee in compressed air, of episode 39 or something, where you can actually study how to use the cyclograms, meaning that each single production line might work in various conditions. So meaning that you have switch on, switch off, different actuators and so on. So this is already a desktop-based engineering tool that helps to create a twin, a digital twin, or a model of the entire system. And how it works, we have here the component database, both generic component as well as the specific of the suppliers that are presented in our platform, as well as we can create the entire diagrams here from the single consumers. Like here, for example, you can see some processes like packaging, drying, and so on. So there we need to know the flow and pressure levels. And then we have here, for example, now I put my system and I have here the length of my piping. And what it does, the system calculates back. I need to check here the regulator. So it calculates back into the compressor room. Here now you see the problems. And the problem here, for example, is that I have the high pressure drop that is extremely high, 26 psi. And the system has both. It has the recommendations as well as the alarms where we have some bigger pressure levels. So for example, here we minimum possible diameter, meaning that the pipe here is oversized. But of course, for piping for us is very important when it is actually undersized. So, and what we have here, we have the problem with the regulator. So something is wrong with the setting of the regulator. So the regulator needs to be replaced. And here we have the pressure drop, and the system tells us that we need to substitute the pipe. So I change here on the click of the, so usually it has in the list the pipe that is suits perfectly here. And then it recalculates back. You see, I don't have problems in the regulator. I either need to fix the regulator, but the pressure drop is very high there, or I can see what are the problems here. So, and then here I see the required PSI, flow. Also, you can change here into the other systems, use any units that you want. And then here I have the flow. I have a new compressed air cost, electricity  and of course, what else I have here? compressed air cost, meaning that for me it costs to operate the system $161,000, euros, or whatever, we put just money to operate the system. The moment I start to change and modify it, for example, I replace this packaging line, I have some open piping, it recalculates again back from the consumer until the compressor room, and I have the full system that I can actually operate. I have this model, and I can change it. I can see what if I change my compressor cost, what if I replace the compressor room, for example, what if I get the more efficient compressor, how much it's going to be, how my demand side works. I also can simulate here the leaks. So I have here leaks. I can simulate the full loop of the system. I can size various reservoirs. And so on and so on. So there are many different types of application. I can do also the cylinder calculations, different cyclogram for this. I invite you to watch our videos about the EasyCAS, how it is different from other simulation tools, because first of all, it's way easier. You can just drag and drop components here and you can calculate and see where the problems are. So, and then you can size the components, you can model a lot of things, and well, enjoy very good engineering software. So the next step will be what we do next. And next, we need to have some action plan of our EasyCAS, right? So we did the model. So we did the model system diagram. And well, now we just enjoy the final reporting and final project management tool. So what we have here all data extracted from the system overview, from the annual cost and CO2 emissions, energy flows, supply pressure, and so on and so on. We have some information about the utilization, baseline summary. Extremely important point here I want to add: the only AI we use, it is the Gemini LLM model that helps to write summaries. We don't use any machine learning in our algorithms. It is extremely important for me to say, because I don't want to hype on the AI as that we have AI use it, because AI should be used for physics, for the engineering applications, only when we reach the limit of understanding the physics. So if we understand the physics very well, and we can actually establish equations and dynamic modeling of the 1D modeling of the lumped parameters, of the concentrated parameters, meaning that we can connect nodes of different components, and using the physics, using the ISO standards and physics, and then validate this model against measurement, we don't need the machine learning algorithms. And this is why it is not a black box, it is a physics, thermodynamics that we use for in our software. The only AI that you will see, it is the standard applications that exist nowadays, just to write summaries for report and make it a little bit quicker. So what we have here? We have here the full project management tool that is connected both with your dashboard from here. So if I go, it calls Project Studio. So you simply go into the open your tool, and this is the full other project management tool that has information about the supply equipment, the piping distribution, production areas, demand air application, all the photos that you collected before, calculations that you done before, and it has also the EasyCAS, let's say before and after. So you have here the system overview, you have the optimized model, and here you have the finding and opportunities. And those finding and opportunities is actually the components that are transformed. Let's say all these alarms are then here in the findings and opportunities. And then what I can do from this finding opportunities, I can add maybe finding that when I do the walkthrough of the facility, I can also write a detailed description here. I can also do some summaries here and so on and so on. And then I can have my bill of material that I can directly extract from EasyCAS. So once you here do the upload to web, you will have the bill of material. Just for sake of time, I'm just going to save it like this. And then here you have then the action plan. And this basically action plan, it's extremely important because, yes, of course, you can't have the all amazing model done, but if you're not going to do anything with this, probably the results will be zero results. So what we have in action plan? So in action plan, we can import from finding and opportunities, we can import it. And here you can see it, and then you can convert the finding into action. I mean, maybe you find something useless and it doesn't make sense for you. We have a really great, usually experts that work with these tools, so you can decide yourself. And then if I want here, have here reduce the pressure drop, I have the description of this. Here I have some problem with the dryer. I can actually name member of a team from this. I can say, okay, this action now is in progress. I have a highest priority in this. It will cost me $2,000. I can calculate installation cost, some savings, right? Some comments also here. So it is an actual project management tool. And then here I can see what is going on in the progress, what is the idea. And this is your tool that you can use based on your calculation. Of course, we cannot leave apart our CFO, our people that accept budgets. And if I do the projects early enough, maybe still in 2027, some exciting projects in compressed air optimization will be started. So here we have an ROI calculator. ROI calculator has all the information from the bill of material. And remember, you can request BOM quotes through the platform, through the suppliers that you chose, or you simply just edit manually. So it has a variety. You can import from PDF, add from our marketplace, edit manually. So nothing stops you and your creativity from where you can order this component and get the offers, compare those offers. So in here you have the investment breakdown. Maybe you're lucky and you have you're participating in the rebates or utility incentives. Installation cost, again, will be the sum of everything. And here you have the ROI timeline information for the summary, as well as the actions by payback. And finally, after all this, we go into our reporting. And what you can see a lot of exciting things in the reporting, such as we had a baseline that we built thanks to EasyCAS. Then we optimized this baseline thanks also to EasyCAS, and we exported it to the reporting software. Here you can see the savings, also the CO2, the flows, the pressures reductions, as well as the information here, final investment summary, findings, and action plans that actually accepted through the team. So you have entire baseline summary, the system diagram, and you can simply print it, export it, generate it, and very exciting thing, you can share with your customers. That's the full spectrum of the tools that we have, and basically everyone is invited here because it can be from the auditor if you're working not just on the compressed air systems, but you work, for example, in the heating or refrigeration, for example. And of course, your customers, they have compressed their systems, you can simply start collecting information, going into these tools. And the most exciting thing that I think we are building now, and we're going to launch by the end of November, is the thing that you will see very soon inside your dashboards. And basically experts. So we have here in the ecosystem the suppliers. So you can see the catalog, you can see different components, all living digitalized catalogs connected to the tools. But what you're going to see very soon in our system, it is an expert network. So from the audits to energy login, to flow pressure, to ultrasonic testing, to actually setting up the system for you, you will have an ecosystem, a platform for the experts that can help you with this. And so we are going to roll it out starting to the end of the year, because we already have a lot of people that are interested in learning this, in providing also these services, because we as a team, we cannot manage all the requests that we have right now. So if you're also interested in learning how to use it, if you are working on the compressor application, please let us know. We will be setting up very soon the training sessions for this. And again, it's not like simulation tools that are extremely sophisticated, where you need the years of the application, of the in this. So it's rather very quick tool that can help the customer then and facilitate to go further. So I can't believe it's been already almost an hour. I'm very happy that I actually managed to fix everything in one. And we will be having also the training sessions. So please be sure that you subscribed on LinkedIn. Be sure that you follow me, you follow Danny. From LinkedIn, you follow also Lisa from the business development, our marketing team, Andrei, our engineer. So he has also very cool sessions, usually like once a month, where he shows how he uses EasyCAS for customers. And bring your projects, bring your ideas. What I think is very exciting about work, and why I love it so much, every week we have a new requests. So someone wants to calculate this system, someone that wants to calculate this system, and we, for example, don't have this capacity, we don't have this function yet. So what we do, we get super excited. We're like, yeah, now we're gonna calculate also this system. And simply with two engineers, one developer, we sit, we check the implementations, we run the calculations, we test it very quick, compare it against the measurement data, and the feature is there. So if you don't find something, if you don't find some component, if something is missing from generic component, some calculation is missing, let us know and we will be happy to integrate it. I want, first of all, to thank all of you who participated today, and all our followers, all people that are using this. And I truly believe that we can make the efficiency attractive and sexy again, and not just like some burden projects, because becoming something new that we all can create together with the participation of really great engineers that are bringing us feedback every single day, it is an extremely exciting project. Thanks everyone, and enjoy your summer.